Good morning, class.
Good morning.
Yeah, we're going to redo something we did yesterday in my third period class because apparently my mic was turned off. But hopefully you can hear me. All right. So what we did yesterday is we talked about polynomial functions. I'm going to create a function, and this function, Marley, thanks for not talking. This function is going to have real x-intercepts, all right, which means real solutions, real roots, real zeros, and we're going to have this thing called imaginary x. Yes, imaginary. All right. So I'm going to draw a graph. Ready? Here we go. Now listen. Here we go. It's going to go up. You draw with me in your journal if you want, and go down. Yes, we did. You don't have to draw this. All right, and then we're going to go up, and we're going to go down. This is like an awesome roller coaster that one day the big will make. All right, so here we go. This is a function that has real roots and imaginary roots. Now, let's review real quick. How do we know something is a real solution, like a real number that's a solution? It's where it crosses the x-axis. So right here, this right here, I'll change colors. Put it in green. I like green. Reminds me of the money that I don't have. Good times. All right. Now, so how many real solutions? Put real solutions. Oh, that's not how you spell solutions. That's solutions. That's like even better. Okay. I'm here all day. I accept tips, but I can't really because that would be unethical, so I can't accept tips. But I can, Casey, accept these famous Amos cookies that you brought me. Thank you. They're delicious. I'm going to eat one right now.
How about I say?
What's another famous name for What's another name for solution?
Roots.
Root. I like it. What's another name for root? X-intercepts. I like it. Now, the last person I'm going to ask is Caitlin Idle because she's talking while I'm talking. What? Oh yeah, it's recorded right here. Now, I'm not going to say your real name to protect the innocent. No, I said with famous Amos cookies in my mouth, so people couldn't hear it really. All right. So listen, we have solutions, roots, x-intercepts. Is there another way to call a solution a root, or what's another synonym? I'll give you a synonym. It's like words that mean the same thing, but they're not the same words. Right? Zeros. Very good, Noah. Thank you for saving her. Yes, zeros. These are all words that represent where it crosses the x-axis. So, how many do we have? We have 3. So right here we have 3 real solutions. However, if I asked you, if this was a drawing and you had a test coming up, say next week, which you do, all right, and I said, hey, what's the degree? No.
4.
Let's see what it is.
It's 5.
You think it's 5? All right, so let's think about it. Now, what do we have to do to figure out what the degree is?
You have to draw another x-axis and see how many times it goes through the whole one.
Yes! She can be taught! I'm going to do what she just said. That was awesome. I cannot wait to listen to this later. Hopefully the mic is on. All right, so I'm going to draw another x-axis, a fake one. This is a fake x-axis, but it's going to test to see what the degree is. I like it right here. Oh my gosh. And then I'm going to say, if that were the x-axis, then that would be a solution, and that would be a solution, and that would be a solution, and that would... It's kind of getting annoying.
5. I have a question.
1, 2, 3, 4, 5. Before we say a question, right now we know it's going to be a degree of 5, and that's right, Morgan. You were absolutely correct. I know other people were correct, but you're the one that explained it. I'm going to pause it so I can... What was your question? I know. I want to see if you saw that. This is a great question. Go ahead.
Okay, how do you know where the imaginary x-axis is?
All right. So what you're looking for is you're looking for the maximum number of times. Listen. You're looking for the maximum number of times that if you were to have an x-axis somewhere, you would draw it. Now, listen, you wouldn't want to draw, watch here, you wouldn't want to draw the new x-axis here, because that only crosses it what? Once. And you wouldn't want to just draw it right here again, because once again, that only crosses it 3 times, right? So you're looking for the place. So you're following the graph. You're like, okay, it goes up and down and up and down. You're like, where could I draw where I know it's going to cross the most possible places? So you're kind of, you're estimating, you're looking at it. I'll do another quick one real quick. I'm not going to, if I do like this, okay? Now there's multiple places you could draw one in, okay? You could draw one in right here. Is that better? No? That is cricketer? Man, are you talking about Nixon? Alright, there we go. Now, right here, that's a place you could draw it in and it would work. Because you have what? You have 1, 2, 3, and 4. You could draw it still. You could still draw it up here. It's pretty easy. There's a lot of room for air. Or there's a lot of ways you could draw it in x-axis, and it's going to cross how many places? 4. The one that we did, though, there was a little window. See what I'm saying? It was a little bit more difficult because you had to draw it in right. I could draw it in here. That would work. But then I couldn't draw it here because then it would miss out on what? It would miss out on these 2 zeros. So when you're drawing in that imaginary x-axis, all right, like a horizontal line, you're figuring out where would it cross where you would get the what? The maximum number of zeros. Okay? All right. Take a little breather here. There we go. Now, if your degree is 5, and you have 3 real solutions, how many imaginary would you have?
2.
That's right, not 5, but
2?
2.
Oh, because 5 minus 3 is 2. Got it.
Yes! We are learning today and semi-having fun. All right? I'm having fun. You guys are miserable. Not all of you, some of you are. Not you. I'm not all right? Not you. So, once again, if the degree is 5 and you have 3 real solutions, you would have 2 imaginary, because 3 plus 2 is 5. That's it. All right, now, what we're going to do now is this is the easy part. Now we get to do the fun stuff, which is the more difficult stuff. So get your journals out, everybody. We're going to continue where we left off yesterday.